Okay, so here's the deal. I've been doing the advent of code for a while, and I wanted to do a live stream of a solution. This is totally improvised. I haven't seen today's advent of code. So if you don't know what advent of code is, look at Advent of Code 2022. You go to AdventOfCode.com, and there's daily challenges all the way starting. It started last December 1st, and it's going all the way up to December 25th. And yeah, I'm just going to improvise the solution of day 5, which I haven't done today. So let's see how this goes. I'm going to use Python today. I want to use other languages some other days, but let's do Python. I'm also live streaming today, so this is new. Okay, so day 5. What are the elves up to today? The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. This is so contrived, it's hilarious. I love this. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves, oh those elves, what are they up to? The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. Okay, so here's the meat of the problem, I guess. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. Okay. For example, okay, so in this case, we are, okay, so basically the elves, okay. Since I'm streaming, I'm kind of self-conscious right now, so I'm not paying too much attention to the problem setup. Anyway, so apparently move 1 from 2 to 1, move 3 from 1 to 3. Okay, so in this case, this example, there are 3 stacks of crates. Okay, 3 stacks of crates. Stack 1 contains 2 crates. Okay, crate Z is on the bottom and crate N on the top, and stack 2 contains 3 crates from the bottom to the top. They are crates M, C, and D. Finally, stack 3 contains a single crate, crate P. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this configuration. Okay. So this is the initial setup of the crates, and then move 1 from 2 to 1. So I'm going to move, yeah, so I'm moving basically 1 from 2 to 1. So D to Z, I guess. Yeah, that's what happened. Great. There were some people live watching, concurrent viewers, and now there's nobody. But it's terrifying to have a concurrent viewer. So okay, I don't want to be distracted by that. And then move 3 from 1 to 3. Okay, so that's the first step. And then move 3 from 1 to 3. Okay, so we're going to move all these 3, and they're going to end up stacking at the top, and they end up, and you move them in the order. Okay, so they maintain order. 1 by 1, of course, they're crates. Then both crates are moved from stack 2 to stack 1. Again, because crates are moved 1 at a time, crate C ends up below crate M. Okay. Finally, 1 crate is moved from stack 1 to stack 2. If they're going to ask me how to solve the problem of crate configuration, it's going to be hard. Let's see what they're asking. The elves just need to know which crate will end up at the top of each stack. Okay. In this example, the top crates are C in stack 1, M in stack 2, Z in stack 3. Okay, so they're going to give me instructions of what to do, and I need to figure out where the stacks are. Okay. you can combine these together and give the else the message CMZ. Okay, that's the final message. After the rearrangement, what's going on? What crates end up at the top of each stack? Okay, let's get a puzzle input. Here we go. This is the puzzle input. So we have the initial configuration and then all the moves that we had to do. Oh Lord. This is insane. Okay, here we go. So let's store this input right here. So first let's create a new folder for day 5, and then here I'm going to create a new file which stores all the input, and let's call that input. So here we go. So we need to do all these moves on this. So the first thing is to read this into what's obviously going to be a, well, it's base 1. No, I can get away with a list in this case. Okay. So let's start with part1.py. So let's read the header. The header is, yeah, until the word move appears. I guess I need to read, oh my Lord, this is insane. I guess it's formatted. Yeah, I can separate by braces, and I can, no. I need to read it with the correct formatting. Okay, so let's read the first 10 lines, or until one line is like this. Okay, let's start from that. For line, so this is going to be reading the header. Read the header. Okay, for line in open input for reading, like so. Here we go. Okay, sorry about that. There was something that bothered me. Let's read those lines. Okay, so they should be at stable positions. So if we read a space, let's enumerate also. Line number is going to be an enumeration of this. Enumerate. And let's do if line number is equal to 8. Actually, you know what? If let's go for this. If the length of the line is 0, then we'll break. And let's print out everything. So let's go for print, and let's say line number, and then the line column and the line. Let's just get that, and we're getting everything from, okay, good. Oh no, we got everything. So we need, if len of the line is this, so actually let's start out with a stacks. Our stacks, what are they looking like? And we're going to use lists for our stacks. So we're going to fill up the stacks from 1 to 9. Here we go. So we need to read this into lists. So the first list is going to have these values, F, R, W, and I need to do it in a last in, first out. So last in, first out list. Here we go. So let's do that. So for each line, I'm gonna read the specific positions, I guess. So let's start at position, should be 1, should be a W. Okay, so let's get the first position of each line. The first position at each line should be line 1, right? And let's, I guess let's call this 1. Let's start at position 1. And I'm going to read. This is hard. This is a harder problem that I should have. Yesterday's problem was pretty easy. Today's it feels a bit harder. Or since I'm streaming, then it's also making noise in my head, so I can't think straight. So I'm going to read the first character in each line. So this should be line at pause. and I'm just going to output that to the command line. I should get the first line of everything. What did I do? Line pause. Okay, so there's some lines. Oh, the final line is going to be empty. So okay, so the line 0 has nothing, so get nothing, and the final one FRW. So that's what I expect. The lines that are empty though. Oh, this is tough. Okay. No, these are not empty lines, so I have characters all the way up to the end. So I should be able to do this for all lines, and then except for the last one. When we hit the last one, then that's when we should break. So line 8. I can't do that when the line is the next one. Yeah, of course I can't do this if okay, so we'll break out of this loop at that point. Okay, now what? Now we can skip 2 characters. It's actually 3 characters, so we can skip 3 characters and read the rest of it. So let's do it in a simple way. That's going to be the line. And I'm just going to read out, so I'm going to say for I in range 9, because it's 9 bins that I need to read. Yes, so I'll do the following. I'll say the character, or the crate, is going to be line at pause position plus I times, I guess this could be a 1, I times 3. And let's simply crates. I think I'm overcomplicating this. Anyway, let's just add crates plus equal crate, and then at the end of this we print the crates for this line. Okay, I think that works. So in this case, for example, in the last line, which is this one, so it's doing this for each line number. Okay, this does not look good. PC, so I just have C. Let's also add a new line at the end of here. So I'll add a manual new line like so. I think that looks better. And line, why am I getting this though? So the first input is PCC. Let's start with a new line here so we can print out. Let's see if this looks better. This is hard. This is hard actually. PCC and then this is not making any sense. Because I'm reading characters that I'm not supposed to read. Okay, so the first is gonna be, let's start at, this is gonna start at pause plus I, so this should be a 1, and then skip 3. This is not going the way I expected. Never mind, we move onward. So the first line is PCC. I should be getting the crates the next one is going to be nothing and nothing. Okay, so I'm getting a lot of, and then why is that happening? So I'm going to start at position 1, which should be this one, and then I'm going to skip 1, 2, 3, and then I'm going to read the next one, which should be P. But instead of that, I am getting this one. So is it 4? It's not 4. It's not 4. Oh, PCC. Here we go. For some reason it's 4. I was not thinking that correctly. Okay. It does not matter. It does not matter. Let's remove these. Okay, so how does this look? So I'm getting nothing, and then P, and then 4 spaces, and then CC. This is taking way too long. I don't like how this is going, but okay, let's move on. So now, for each crate, for each position, I can actually add a crate number. I'm not gonna, if there's nothing there. Oh, and I need to add these in first in, last. Okay, so it's last in, first out. So that I'm gonna add the last one into the list. So I need to add these crates into the list. So that's the important part. Man, even the setup of this is taking these way too long. So anyway, stacks. Stacks are gonna have crates. So stacks, let's just go ahead and hard code this stuff. So stacks, if we hard code it to be a list of 9, yeah, I'm just going to create 9 empty. A stack is yeah, these are the stacks, and it's going to be 9 lists. It's an array of a list of lists, basically. So stacks at I, so the ith stack, and if crate is not empty. So if it's not a space, so not equal to a space, stacks I. So do I want to push? I want to push from the bottom up, so I want to get this reversed. Okay, so let's push the crate, and then we read from top to bottom, I guess. Yeah, last in, first out. Okay, so that's how it's going to look like. Does this execute? No, because I am dumb and I'm missing the column there. Push. Oh, so it's not push, append. Append is the correct. Okay, so let's print our stacks at the end. Print stacks. I'm not even done. Okay. And we should, if it's a number, by the end here, I should just quit my life, right? So if I'm at this level, so it's not even this. So if it's line number, I guess line number 7. Line number is 7, then I'll do that. Double equal, like that. That works. Now the thing here is that I'm gonna wanna keep this open, so let's do something else. I'm gonna open the file externally, because I wanna keep reading, right? Let's close the file just to be gentlemen. And this 4, I'm gonna have to implement it in a different way. So I'm actually gonna say the following. I'm gonna say for line number in range 9, like that. And I'm gonna get the line from a read line. Line is fid.readLine, like this. And then if I get the line like that, if I read it from, then I can just keep reading afterwards. That works. So the file will continue. So this is the input file. We're done. We should be at this level. If I read one more line here, I should get those numbers. So line equal fid.readLine, like that. And did I do it right? The next line should be, oh, and I'm not printing it, so print line. The next line I'm getting is actually a space. Okay, that's good. It's the next line. But if I read one more, let's do this one more time. I should be getting the moves. And that's where I want to be. That's where we want to be at. Okay, so I'm getting the moves. So from now on, it's moves all up to the end of the input file. I don't know how many those are, but let's just do it. So now I'll move on. For line in fid, like this, let's just print all the moves. Print line, like that. And am I getting what I want? Yes, it doesn't start again. So move 2 from 4 to 9. There we go. Problem solving in real time. Okay, so this is the line now means the moves, right? So this line, I'm actually going to separate move 2 from 4 to 9. So the first thing is I'm going to sanitize this input. I'm going to go for line equals line dot replace. Let's get rid of the words, shall we? Let's do that. So move. This is probably dumb that I'm doing this, but okay. Move, I'm going to replace for this, and I'm going to replace from. I should probably just be reading, okay. No, I'm going to do it right. Like this. So I'm going to say at character 0, 0, 1, 2, 3, 4, 5 is how many. So how many is going to be line at, this is, again, I lost numbers, so 1, 2, 3, 4, 5, 6, I guess. Line at position 6. And then, how many characters after that? It's, darn it, 6 characters after that, so 12 is going to be from, and that's a reserved keyword in Python, so just from, and 2 is going to be line, 4 characters I think after that, so 16. Let's just print this out, so print like this with an F, and let's use this special how many, and let's say from, and let's say 2, like this. How many? 9 from nothing to oh, no, that's not working. So let's see where the error is. I probably need to add an offset. From move 5 from 2 to 9. So how many? It's empty space, so that should be 1, 2, 3, 4, 5. I'm on a 1 off, 5, and then 11 and 15, probably. Let's execute that. How many? 1 from M to, so no, I need to move 2 to the next, okay, so this should be 13. From, no, 4 from, this is so dumb, I must look so dumb doing this. From 5 to, oh, I need to move to the right, like this. Yeah, from 5 to 1. Is this working all through? I think it is. 5 to 9. Okay, now let's turn these into ints. Integers. Like that. Okay. Oh. And the last one is empty. So for line of fid, if we're going to add here a little one that says if length of the line is 0, then we break, so that we avoid that last error message. What line is this? We should be breaking. Oh, move 12. This is not good because these numbers are more than, okay, no, this does not look good. Anyway, So this is not a regular format, and I should have been able to identify that just by looking at it. But since I'm streaming, let's go back to strategy 1. So, strategy 1. What is strategy 1? Let's just replace all the words so we can get from and replace that with the empty string, and move and replace that with the empty string, and to. That way our life is much easier, and then we split a cell, split line, and then we can unpack this into ints. So we can say something like how many is going to be SL at position 0, converted to an int, SL at position 1, convert to an int, SL at position 2, convert to an int. Does this solve it? Yes, it does. This was easier. Don't waste time trying to be all fancy. Okay. So now we have our moves, and cool. I don't need to show this every time. Okay, and if I print the stack, let's see the print stacks. Print stacks, the stack is going to be at 0. I have FRW1. Oh, you see, this is not good. I'm going to read a range of 8, I guess, because I have those numbers at the end. I don't want that. I do not want that. Print stacks, I'm going to read 2 lines, skip to the next. That works. Okay, that's easy. So our stacks looks like FRW, FRW. So the first one is at the top, and the second one, okay, and the last one is at the bottom. That's good. That's good. Okay, so this is the move. How many? And from and to. So, and since the last one, I should probably use a method. Okay, so if I do append, it's gonna look like we're doing it, putting it at the end. Instead, I don't want to do append. I want to do Python list push. Is there a prepend? That's what I want. I want insert. Is there a prepend? Prepend. Extend. There's an extend. Python prepend list. That's what I want. Prepend. There's a prepend command. Well, that's what I can do, right? Prepend to a list. So let's repeat this. So for repeats for iteration, I guess, I in range how many. We're going to repeat this n times, and we're going to from, right? We need to get the one at the first position because that's the one that's at the top, right? So we're going to get the crate is going to be stacks at 0. That's our crate. And we have to remove it from the beginning of the list. So basically stacks at from 0. And stacks at from is going to be stacks from, and let's I think that's right. So give me the rest of it. So I'm actually pulling the last one here and then keeping the rest of it. So this is what this means. And then I need to prepend it at the stack 2. So at the stack 2, like this, I will say that it stacks, it's going to be basically the crate, the list of the crate. So I'm going to create a little list with the crate, and then I'm going to append whatever was there before, so stacks 2. So it's kind of like this. And then we repeat the moves. And this should be able, okay, this should work actually. I think this is the algorithm. So basically, for each line, I detect what the moves are, how many I need to move, how many times I need to repeat the procedure, from which stack I'm taking stuff out, to which stack I'm putting stuff into. So I get the crate name from the first component. This is the one I'm going to remove. So I get the crate name, and then the stack I am taking crates from, I'm just going to leave the rest of the components. So I'm taking the first component, and the rest of them are going to be there. And then the 2, I need to do the opposite. The opposite in this case is going to be put it at the top, right? I'm going to put it at the top, which is putting it at the beginning. If you can see FRW here. So I need to put it at the beginning, and this should be it. And by the end, so does this work? List index out of range. This is not working. This is horrible. This is a tough problem. So list index is out of range for what? Move 2 from 4 to 9. Move 2 from 4 to, and why doesn't it? Ah, because our indices. Okay, so from, I should be subtracting 1. That's why. That works. So okay, so now I just need to report what the top. Man. So after the rearrangement procedure, what crates end up at the top of each stack? That should be easy. I should be able to do 4. Let's do just print stacks. Stack 0 for stack in stacks. That's it. So just print the top. That's the end. So I'm getting CVC, and let's turn that into a string that I can copy paste, because why not? Because I can waste more time. So let's do the following. So top crates are gonna be, it's gonna be the empty string, and for stack in stacks, I'm just gonna go top crates plus equal stack at 0, and then we print out the top crates like that, and this is what's at the top. And I'm a bit scared because this is they're repeated letters, but I guess there are repeated letters here. Yeah, that's a bunch of repeated letters. Let's see if this works. Boom! It took a lot of time, but we did it at the first try. So okay, and we're clocking at 35 minutes. Great. Perfect for streaming. Anyway, here we go, part 2. This should be easy, so let's start with a new, the input usually doesn't change between parts, so. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it. The crane isn't a crate mover 900, it's a crate mover 9001. Those are very different crate models, crate mover models. They should know. The crate mover 9001 is notable for many and new exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Oh no. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this new configuration. Next, both crates are moved from stack 2 to stack 1. They return their order as well. Finally, a single crate is still moved from stack 1 to stack 2, but now it's crate C that gets moved. In this example, the crate mover 9001 has put the crates in a totally different order. Before the rearrangement process finish, update your simulations so that the elves know where they should stand to be ready to unload the final supplies. After the rearrangement procedure completes, what crates end up at the top of each stack? Oh my lord. Okay, so now I can move the ability to pick up and move multiple crates at once. So they pick up all the crates at once, I guess. Yeah. Okay, so this should be fairly simple. I just need to retain the order. Okay, so retaining the order. I just need to be careful about how I do it. So now how many, so this part changes. This part changes. So now I'm going to, yeah, this is the part that changes for part 2. So instead of doing like that, and actually crates, the crates are going to be stacks from, and I'm just going to take 0 through how many. That's what I'm going to do. And then stacks from, I'm going to erase, this is the same algorithm except stacks from now start at how many, like this, and then stacks to, we should take the crates and append like this. I think that's all we need to do. This runs, and this is the new result. Let's just go for it. Just go for it. And that's the right answer. Wow. Lord, I took half an hour to solve the first part just because it was all reading that silly header, and I was out of my head a little bit there where we started. But then this other part was so simple. It looked horrible, but it was simple. So that's all. Let's tweet this out, and maybe I'll do another one of these streams. If you like it, just let me know and I'll do another one.